everybody. In this video, we're going to be looking at topic 4, lesson 2, example 3, graph a function in the form of ax plus b divided by cx plus d. So what is the graph of this function? So the first thing I'm going to do is I'm going to grab this function, bring it over here, and I'm going to look for my horizontal and vertical asymptotes. All right, so right here, I'm going to look to see what value my denominator cannot be. So if x is equal to, let's see, add 4. So we get 3x equals 4. Divide this by 3. I get x equals 4/3. And in all actuality, it cannot equal 4/3, which will make that my vertical asymptote. So my vertical asymptote is when x equals 4/3. Now looking at my horizontal asymptote, remember the 3 cases from the last one. If the degree in the numerator is less than the degree in the denominator, then my vertical asymptote is equal to 0. In this case, my degree in the numerator is 1, my degree in the denominator is 1, so that case does not apply. If the degree in the numerator is greater than the degree in the denominator, then I don't have a vertical asymptote. Well, again, they're both equal to each other, so that case does not apply. The third case is if the degrees are the same. And if the degrees are the same, you're supposed to use long division. But as I said in the last video, if you take your coefficients, divide them from each other, you'll get your horizontal asymptote. All right. Now, let's continue on. Let's graph this function. And it's just a sketch, I believe. I can also plug in points. But let me grab my graph here. And what I do know is that I have asymptotes. Let's put that away. Or not, oh, there we go. At 4/3 and 2/3. 4/3 and 2/3. So I'm going to make this. This is 1/3, 2/3, 3/3 or 1, 4/3. All right, so let's put my little dotted line here. I don't like that. I'm going to put it in gray. 4/3 here. I don't know why I have the arrow one. And then 2/3 here. So a rough sketch of this graph. Would look something like this. And again, to be more accurate, you could plot the points by substituting x values in. So when x is equal to 0, this is -1/4. So here we should be -1/4. So here we should be like here, or like that. All right, so I would plug in and plot the points. Okay, let's go look at their graph before timelines of this video. Okay, we found the vertical asymptote. We found the horizontal asymptote. And then we sketched the graph. So indicate the asymptote, choose x values on either side of the vertical asymptote, evaluate the function in a t-table, and then plot the points. A common error here is the ratio of the leading terms cannot be used as an approximation unless x is approaching positive or negative infinity. All right, so there you go. There are your triads. And I will catch you in the next video.